Aircraft maintenance check. Introduction. Aircraft maintenance check refers to the various inspections and procedures performed on an aircraft ensure its safety, airworthiness, and reliability. These checks are performed at different intervals and CA vary in complexity and scope. There are several types of maintenance checks, including the pre-flight check, daily check, weekly check, and the more comprehensive A, B, C, and D checks. Each of these checks involves a different level of inspections and maintenance, ranging from a quick visual inspection to a complete teardown and rebuild of the aircraft. Maintenance categories. A, B, C, and D checks are four of the most common types of aircraft maintenance checks. These checks are performed at different intervals and involve different levels of maintenance work. Here's the brief overview of each. A check. A check is the most basic type of maintenance check and is typically performed every 400 to 600 flight hours depending on the aircraft type. This check includes a visual inspection of the aircraft system, structures, and components, as well as basic functional tests. It usually takes a few hours to complete and can be performed on the ramp or in hangar. In A check, in A in A check, A and B check are the lighter check, while the C and D are the heavier check. So in A check, it consists a visual examination of the airframe, power plant, avionics, and accessories to ascertain the general condition of the aircraft. In the manpower needs here is 20 to 60 man hours. And in A check, it also takes 200 to 300 cycles. One cycle means take off and landing. B check, also known as light maintenance check, is a more extensive check that is performed every 6 to 8 months, depending on the aircraft type and usage. This check includes all the tasks of an A check plus additional inspection and functional tests such as engine checks, hydraulic system checks, and landing gear inspection. It is typically takes several days to complete and is performed in a hangar also. In B check, every 750 it in B check every 750 flight hours, and it include A check plus selected operational check, fluid servicing and lubrication, as well as an open inspection of the panels and cowlings. And the manpower need here is 200 man hours. C check, also known as a heavy maintenance check, is a comprehensive check that is performed every 1 to 2 years, depending on the aircraft type of usage. The check includes all the tasks of a B check plus more extensive inspection and functional tests such as removing and inspecting components and on a critical moments. It is typically takes several weeks to complete and is performed in a maintenance hangar. The C check includes the A and B check plus detailed inspection of airframe, engines, and accessories, heavy lubrication, and a portion of the corrosion prevention program. Flight controls are calibrated, major and internal mechanisms are tested, and service bulletin requirements are fulfilled. About 72 hours of ground time, and the manpower needs here is 3,000 man hours, depending on the aircraft. Last is the D check, also known as complete overhaul check or the heavy main visit or the HMV. It is the most extensive type of maintenance check, and it is typically performed every 6 to 10 years depending on the aircraft type and usage. This check includes all the tasks of a C check plus a complete disassembly and inspection of the aircraft structure, systems, and components. It typically takes several months to complete and is performed in a dedicated maintenance facility. In the check, it includes removal of cabin interiors to allow detailed structural inspection, essentially stripping the aircraft of to each shell and revealing the interior. Here is about 21 days of ground time, and it needs 10,000 man hours. Overall, A, B, C, and D checks are critical to ensure the safety and airworthiness of the aircraft. They are performed by qualified and trained maintenance personnel according to strict regulations and guidelines set forth by aviation authorities.
Okay, so for the checks and protection, we have the protection against ice formation, which talks about the aircraft and engine ice protection systems, which has two designs, which are the de-icing system and anti-ice system, which either they remove the ice after it has formed or they prevent it from forming. So the de-icing system, it talks about that it utilizes a variety of means to transfer the energy used to remove the ice. This allows the consideration of mechanical, principally principally pneumatic systems, electrical and thermal methods. So um, the second system is about the anti-ice system, which is the reverse paradigm, which tells us that if properly used, they prevent the formation of ice continuously, resulting in a clean wing with no aerodynamic penalties. An anti-icing system must have a means of continuously delivering energy or chemical flow to a surface in order to prevent the bonding of ice. The typical thermal anti-icing system does this at a significant energy expense. The concept is not viable for aircraft that do not have the requisite excess energy available during all flight phases. So, for the next is aircraft fuel system. So, fuel system differ greatly from aircraft to aircraft due to the relative size and complexity of the aircraft in which they are installed. In the most basic forms, a fuel system will consist of a single gravity-fed fuel tank with, with the associated fuel line connecting it to the aircraft engine. So, in the ram air functions, in a modern multi-engine passenger or cargo aircraft, the fuel system is likely to consist of multiple fuel tanks which may be located in the wing or the fuselage or maybe both, and in some cases in the empennage. Each tank will potentially be equipped with internal fuel, internal fuel pumps, and have the associated valves and plumbing to feed the engine, allow to refueling, and the fueling isolate the individual tanks, and in some applications allow for fuel dumping or for optimization of aircraft center of gravity. Next is the fuel temperature control. So, um, turbine-powered aircraft operate at high altitude where the temperature is very low. As the fuel in the fuel tank cools, water in the fuel condenses and freezes. It may form ice crystal in the tank or as the fuel or water solution flows and contacts the cool filter element on its way through fuel filter to the engine or engines. The formation of ice on the filter element blocks the flow of fuel through the filter. A bulb in the filter unit bypasses unfiltered fuel. When this occurs, fuel heaters are used to warm the fuel so that ice does not form. These heat exchanger units also heat the fuel sufficiently to melt any ice that has already formed. So next is protecting the engine compartment from overpressure. So this one is se- completely self-explanatory because um, the engine compartment needs to be protected from pressure, or if you may notice, the engine compartment has two holes, which is the intake and the outlet of the air pressure, because the engine compartment needed air for it to run specific functions. And as we all know, when the aircraft is um, currently on mid-flight, the pressure on high altitudes or the air pressure on high altitudes are so strong that uh, in the engine compartment just um, they just have a specific pressure intake so that it allows the engine compartment not to be damaged or to be completely over pressure. So next is the visual inspection. This is a very common and self-explanatory because this visual inspection talks about the 360 walk, which is the um, 360-degree walk on the aircraft before the flight or the upon pre-flight checking. So in this 360-degree walk, um, we have a designated spots and numbers to be checked on the aircraft in and out before it take off. So that's in the visual inspection. So next is checks at the engines before takeoff. So here, engines are needed to be checked before takeoff because you cannot re you cannot repair or compensate the engine while in mid-flight because of course you cannot um, do proper proper fixing of the engine while it is in mid-air. So upon takeoff, you need to check the engine so that you might uh, before the flight you might be able to repair or um, to know what would the engine would be, or if the engine has a problem or has a loosened bolts or has a problem. So yun. In the compressors, so compressors are um, the compressor section of the engine has the important task of providing um, a sufficient quantity of compressed air to satisfy the requirement of combustion. So that's need to be checked because it increases the pressure of the mass of air that is received at the inlet and provides it to the combustion section at the required pressure at the required pressure. So next is the bearings. So bearings need to be checked uh, before and after flight because bearings can be loosened due to the friction and vibration uh, mid-flight or on-flight, and sometimes bearings are over or are tightened or too much tightened, which may damage the engine or the system that would be need its bearing. For example, is the um, the for example is the aircraft instruments that mainly has bearing. So if it is too tightened, the instruments might not be able to read the exact or the appropriate readings, and may cause you an accident. So oil system needs to be checked and protection because oil system must be lubed clean after and before flight so that um, it would not generate too much stress on the aircraft, and that should be all. Um,
So next is the checks and protection. So in inline checks, there's a pre-departure check, after departure check. So in the inline checks, generally refers to the security checks that passengers go through before boarding a flight. These checks are mm, these checks are conducted by the airport security staff and are designed to ensure the safety and security of passengers and crew members. So the pre-departure check typically refers to the process of checking in for a flight before departure. This may involve presenting identification, checking baggage, and receiving boarding passes. So some of common inline checks or pre-departure checks is the security checks, boarding pass verification, baggage screening, aircraft inspection, passenger count, and lastly the final check. So the security checks are carried out to screen passengers, their luggage, and carry-on items for prohibited items such as weapons, explosives, or other dangerous items. Second is the boarding pass verification. So the passengers boarding passes are checked to ensure that they are valid and match the traveler's ID. The next is the baggage screening. So all the checked baggage is screened to detect any prohibited items such as explosive or weapons. Next is the aircraft inspection. So the aircraft is inspected to ensure that it is safe and ready for flight, including checking the engine fuel navigation system and other critical components. So next is the passenger count, the number of the passengers on board. The aircraft is verified to ensure that everyone who checked in has boarded the flight. Lastly, the final checks. Also, before the aircraft takes off, the crew member or the crew will carry out a final set of checks to ensure that all doors and hatches are securely closed, and that all safety equipment is in place and functioning correctly. So next is the maintenance level. So the first one is level A1. So the level A1 is on engine installed on wing. The level B is on uninstalled engine. Level C is repairing parts. So the level D1 is on accessories, pump, starter, and generator. The lastly, level T1 is engine testing. So next is the engine lifetime. There's a hard time between overhauls, total number of flight hours before overhaul maintenance, specified by manufacturer. So the engine lifetime is the number of the number of hours that an aircraft engine can be operated before it requires a major overhaul or replacement. So the engine lifetime varies depending on the type of engine, its design, and the operating condition it is subjected to. So the aircraft engines are typically designed to be highly durable and reliable, but they still require maintenance and eventual replacement due to the wear and tear that occurs during operation. So the engine lifetime is usually measured in terms of flight hours, so which is the amount of time that the engine is running while the aircraft is in flight. So the actual engine lifetime can vary depending on several factors, such as the type of aircraft, the engine model, and the operating conditions. So for the example, the engine used on commercial airliners or airlines are designed to last longer than those used on smaller private planes due to the high operating demands and the increased numbers of flight hours. To ensure that aircraft engines remain safe and reliable, they are subject to strict maintenance and inspection requirements based on the manufacturer's recommendation and regulatory requirements. These requirements include the regular inspections, repair, and overhauls to replace worn or damaged parts, and ultimately to extend the engine lifetime. So next is the cycle. So depends on the materials used for the engine and fixed for specified materials like one cycle, engine start, take off, maximum climb, cruise, idle, landing, engine shutdown. So in the cycles, typically refers to one complete operation of an aircraft including takeoff, climb, cruise, descent, and landing. This term is often used to describe the number of cycles that an aircraft or its components have undergone, as it can be useful measure of wear and tear. So for the example, an aircraft landing gear is subjected to significant stress during takeoff and landing, and each landing and subsequent takeoff is considered one cycle. So the number of cycles that the landing gear has undergone can be used to determine when maintenance or replacement is necessary. So, for example, a Boeing 737 has a total lifetime of 20 years. So in those 20 years, it has done 75,000 cycles for about 51,000 flight hours.
So types of engine lifetime monitoring. First is on condition, only affects parts will undergo maintenance. So, yung affected parts lang ang i-maintain. So, mostly mga minor parts lang to. And next is engine condition monitoring. So, continuous standard engine and instrument monitoring without additional equipment. So, a process lang siya in monitoring the performance of an engine to detect any abnormalities or potential failures before they lead to a breakdown or costly repairs. Next is preservation and depreservation. For preservation routine is important to protect an aircraft from long-term storage. So, itong routine is very important to um, maintain the integrity and serviceability of the aircraft during long term of storage or periods of inactivity. This routine aim to prevent corrosion, degradation, and damage to the aircraft's structure, components, and systems. So, ang ginagawa mostly example dito is all openings must be closed, anti-moisture should be applied inside the engines, humidity must be monitored, fuel must be emptied, but oil must be filled. Next is the preservation. The preservation is the process of bringing preserved equipment out of storage and back into working order. So, the preservation is um, preparing an aircraft that has been in storage or inactive for an extended period of time for return to service. This process involves reversing the preservation routines and ensuring that the aircraft is safe and operational. So yun nga, parang i-reverse lang yung ginawa sa preservation. Like yung ginawa dun sa fuel, sa preservation, tinanggalan ng fuel yung tank. Tapos sa preservation, refill siya, nag-refill ng tank to the necessary amount lang kaso. Pati yung oil, refill an aircraft's oil back to full, remove all cover from openings. Ganun.
50-hour inspection. The 50-hour inspection can include inspecting the engine for wear and tear and gapping, cleaning and examining the spark plugs. If the aircraft maintenance crew finds any excessive wear and tear, the damaged components are replaced to restore the airworthiness of a plane before it flies. So, this type of maintenance inspection is important because of several reasons, such as for safety, compliance, preventive maintenance, improved performance, and resale value. It is also required by the Federal Aviation Administration for all small aircraft to ensure their continued airworthiness and safety. It is typically performed after 50 hours of flight time or every 3 months. So, overall, the 50-hour inspection is critical aspect of aircraft maintenance and helps ensure that the aircraft is safe, reliable, and operating at peak performance. 100-hour inspection. The purpose of a 100-hour inspection is to ensure that the aircraft is safe to fly and that all systems are operating as they should. During this inspection, all major components of the aircraft will be inspected, including the engine, airframe, control surfaces, and electrical system. The 100-hour inspection is typically performed by a certificated mechanic who is authorized by the FAA or CAAP to perform maintenance on the aircraft. It is required after every 100 hours of flight time or every 12 calendar months, whichever comes first. So overall, the 100-hour inspection is an important part of maintaining the airworthiness and safety of small aircraft and even the wide-bodied aircraft, and it also ensures that the aircraft is operating at its best.